Good morning, everybody. We're going to go ahead and get started. This is Front-End Web Technologies for Geospatial Developers. My name is Davis, and my pronouns are they, them.
My name is Nate, and my pronouns are he, him. So this talk is intended as an introduction to front-end web development. We're going to go over some important concepts in CSS and JavaScript, but we'll also get into some code demos and some tools. If you're new to web development, don't get discouraged. It's extremely complex, and the technology changes so fast, and there are so many tools, it's super easy to get overwhelmed. The good news is it's all HTML, CSS, and JavaScript, and view source is just a click away. And Esri has some great products and resources for many different paths to web development, depending on what your end user needs are and your app's technical requirements. Here's Davis to give us some JavaScript basics.
All right, so first some JavaScript. These are some common asynchronous patterns that you'll see in JavaScript and also in the demos that we'll show later in the session. And when we say asynchronous or async, what we mean is that code that allows us to begin a task. It could take a long time. We're not really sure how long the task might take, but we want our app to be responsive to other things while the task runs, and then ultimately return a result when the task is finished. Writing code in this way allows us to be sure that we'll have necessary data, for example, from a request to an API, and then that our code will execute in the desired order. So promises are one way that we can write asynchronous code in JavaScript. A promise is an object in JavaScript, and it can be thought of as a proxy for a value that we don't know yet. It represents the eventual completion or failure of an asynchronous operation and the resulting value that we get back. Functions in JavaScript can return promises just like any other object or value. And promises exist in 3 states: pending, fulfilled, and rejected. So if a promise is pending, it's still in progress. If it's fulfilled, it has completed with the result that we were expecting. If it's rejected, something has gone wrong along the way and we've gotten an error. So in the snippet on the slide, query features is actually a function that returns a promise. And if we were to log out the return value of query features to the console in the browser, we'd actually see a promise object, not the data that we're expecting from the API. So we need a .then statement. And that just means that the code inside the .then block won't execute until the promise resolves with our expected result. Now, promises are chainable, and that means that it allows us to execute multiple operations back to back in the expected order. One thing to note on this slide are the arrow functions with single-line function bodies. When we use a single-line body like that, we don't need to use the return keyword, and that can make our code even more succinct. That's not unique to promises, it's just a little JavaScript syntax trick. And lastly, you always want to handle any errors with a .catch statement. So if anything goes wrong along the way, we're just going to pass that error along and execute the code that's in that .catch statement. Another pattern we can use is the async and await keywords. And under the hood, the async keyword just means that the function will return a promise. In this example, an anonymous function is marked as async and then passed into an event listener. And then inside our async function, the await keyword is used to get the promise's result. So think of any code written after that await as what's inside the .then statement that would be changed to a promise. Also, like chaining, we can use multiple await statements inside our async function block. And now, using these 2 keywords, we can write async code that reads even more clearly from top to bottom. So what about error handling in this pattern? Well, we just want to wrap everything in a try-catch statement. And that does exactly what the statement implies. Try this bit of code, and then if you get an error, don't worry. We'll just catch it, pass it to the code inside our catch block, and handle it accordingly. So should you use promises or async or await? And I'm not going to tell you which one is better. Different folks have different opinions. But ultimately, it's really important to understand both patterns, especially since async is just written on top of the promise object. Next up, events. This is part of the Document Object Model Web API, or DOM. And to understand the DOM a little bit better, I really like the following definition from the Mozilla Developer Network. The DOM connects web pages to programming languages by representing the structure of a document in memory. And it represents the document structure of the web page as a logical tree of nodes that we can interact with in code. So you could say that the DOM is like the Force in Star Wars, because it binds the universe of our web page together, connecting all of our elements in a way that we can easily communicate with. We'll talk a little bit more about the DOM later. But for now, events are emitted by elements in the DOM in response to a user interaction. So for example, as I interact with a web app, I might click a button, type into an input, scroll up or down the page, and all of these are examples of events being emitted by those elements. So we attach event listeners to either the document, which is the whole page, or individual elements in the DOM to listen for, and then we respond to or handle those events. We can also specify which element we want to listen to. So rather than listen to every button on the page, we can use an ID and say just this one button if we click it. And so we respond to event emitters and get them to perform functionality by passing what's called a callback function into the event emitter. So listen for the event and then do this function. Now, when you have the callback function being passed into the event, you have access to an event object as an argument, and that contains lots of useful data, including the event target, which is the element that was interacted with. And if you're ever in doubt that something is firing incorrectly, or if you're curious about what data you can access, you can just console log out that event or just the event.target. So Calcite components and other web components use something called the custom event interface. This is really similar to native browser events. You have access to the same event argument and the same target element. And Calcite documentation has a great component playground that actually allows you to toggle event logging on and off, and you can inspect the event's output in the browser without writing any code or setting up components yourself. This is a really great time saver when you're setting up your application. And now I'm going to hand over to Nate, and he's going to tell us a little bit more about the Calcite Design System.
Thank you. So Calcite Design System is Esri's collection of design and development resources for creating beautiful, easy-to-use, cohesive experiences across apps with minimal effort. It includes the Calcite Components, which is a library of reusable web components for quickly building accessible, well-designed applications. And Calcite Components are built on a modern browser standard known as Web Components. And Web Components actually refers to 3 different browser technologies: custom elements, HTML templates, specifically the slots, and the web technology with the coolest name ever, Shadow DOM. When used together, they enable reusable elements with custom behavior and styles safely encapsulated away from the rest of the page. And Web Components have been building steam since they landed in all browsers in 2020, and they're really starting to take off. In fact, the Maps SDK for JavaScript has recently made some of its functionality available as Web Components. There's a technical session on Thursday coming up, building apps with ArcGIS Maps SDK for JavaScript components. Be sure to attend that if you're curious about Web Components. You can consume and implement Web Components easily just by adding some JavaScript and markup in your page. But it's helpful to understand how these technologies work and what they bring to the web components. So let's dig in a little more. Custom elements are quite literally HTML elements that have custom behavior, names, and functionality. And they can inherit behavior from existing HTML tags like a p tag or an image tag, or they can be completely autonomous. That is, they have no inherent behavior beyond what the author gives them. Custom elements have numerous callbacks and interfaces to attach behavior to specific events, but what we really want to highlight is custom element registry and when defined. Custom element registry is an interface for registering and querying custom elements with the browser. The browser won't know about your custom element until you've called its define method. Since most custom elements will want to run some setup code, the when defined method returns a promise that's fulfilled once the element is available to the browser. Okay, so we've got an idea how to make custom elements. How do we make them reusable? And it's slots. Slots allow component authors to predefine placeholders within their components. And on the user side, all it takes is adding a slot attribute with a name to an HTML element within the component, and that'll slot that element into the named slot. You can see in this Calcite card example, we've specified the H4 element to be assigned to the title slot, and there it is right at the top. This example has many slots, but some components just have one default slot, and in that case, you don't even need to name the slot. Everything just gets dumped into the default slot. Okay, so we've got custom elements, and it's reusable, but how do we make it safe? The good news is you don't have to do anything thanks to Shadow. So as Davis mentioned, the document object model is kind of the API of HTML. It represents the page to the browser as a tree of nodes. And since JavaScript and CSS can interact with the entire DOM all the way up and down, web components need a way to encapsulate themselves safely from the rest of the DOM. From the page that references them, a hidden DOM, if you will, a DOM in the shadows. So that's the basics of web components. Let's take a look at an app we built with Calcite components and the Maps SDK for JavaScript. So we made a demo app here. And if you don't know, CSA stands for Community Supported Agriculture. Those are small farms that sell shares of their harvest to local customers. Every farm has different products that they offer, and they usually have one or more drop-off sites located around a city. Now, I know what you're thinking, and yes, we're from Portland, so of course we support community agriculture. So typically, when you sign up for a CSA, you pick a farm based on the products you want and how convenient it is to pick up your share. Portland Open Data is a great program, and they've got a really cool data set that has a bunch of information about the farms, all their pickup locations, and what products they offer. So we've thought this is ripe pickings for a web app. So here's Davis to show our app.
There's a map up there, right? Good stuff. All right, so we built an application with vanilla JavaScript, so no front-end frameworks like React or Angular. And we also used Vite, which is a tool that quickly configures a development environment and build tooling for JavaScript apps. And we've also used the JavaScript Maps SDK, Calcite components, and the Calcite point icons library. So in the browser, you see that we have a base map. This is the community base map from the base map styles service. And you see point symbols that represent our CSA pickup sites layer. And if I click on a site, sorry, the Wi-Fi is a little delayed, we see the name of the farm and some information about the pickup site. And then on the left, we have a Calcite panel with our filtering UI, and that's using Calcite input and the Calcite slider components. So when I type in an address and adjust the slider, oops, we see a home point appears on the map, and then as I adjust the slider, the CSA sites outside of our buffer area go to grayscale, like so. And as we adjust the slider live, the symbols change. So looking at the code, I'm not going to go through this line by line, but I'm just going to talk about some key points. So first, in our index.html file, in our markup, we're using the Calcite shell, and this is wrapping our entire full-page map app. You can also use the shell as a component with a width and a height so that you can embed it into other content on your web page. In the JavaScript file, at the top of the page, you see the ES modules that I'm importing from the Maps SDK. And then I'm also setting an API key to the global Esri config object. The API key is configured from the ArcGIS developer site, and I'm setting that using an environment variable. And the Maps SDK will actually pass this key along to the services as needed when authentication is required. So I don't have to handle that myself, I just have to set the key here. So for example, here, I just set the base map that I want to work with, and then the key is passed along and authentication is taken care of when I want to authenticate with the base map service. So if I scroll a little further to the CSA renderer, this is where I'm actually going to set up the look and the symbology of our feature layer. Now, I wanted to use Calcite point symbols to indicate our pickup sites. This is a collection of SVG icons that you can access through the Calcite Design System documentation. And it's a really great set of icons that's designed specifically for mapping. And they have really great iconography with a really wide range of map use cases, really, really specific icons. But I also wanted to customize the icon a little bit. I'm definitely not a graphic designer. Shout out to all the designers out there. We appreciate your work. So what I did instead is that I created a CIM symbol. And these are high quality, scalable, multi-layer vector symbols. And the Maps SDK team has actually built a web app called the Symbol Builder app that provides a UI for creating symbols and exporting them as code snippets without writing any code myself. So this allowed me to upload the SVG icon, then I added the circle layer underneath, adjusted the color and halo effect, and then I exported the symbol as JSON, which I then just reference in our app as a variable. So then a little further down, we instantiate our feature layer, and then we add it to our map along with some pop-up configuration. So next, I want to set up the logic where I'm actually listening to the input, the Calcite input, and the custom event that it's emitting. So we add an event listener to the Calcite input called Calcite input change so that we can start to create our home point graphic. Now, Calcite input change fires on enter or submit, and I chose this event because I don't want to listen to every keystroke in this instance because that would mean I'm hitting the geocoding API with every keystroke. And that would be, it could cause a performance issue, and it's a little weird for the user as well. So next we have a little further down. Oops. We call address to locations, which is the Maps SDK locator method, and that calls the REST API's geocoding service, and we just take the top result from that API call, and we pass it to another function, which is add home graphic a little further down. So this actually takes that location and sets up a point graphic with geometry. We just add it to our graphics layer so that when we click in the Calcite input, we now see our home point on the map. But we also want to create that buffer that I mentioned earlier. And so next we pass that same point geometry to create a buffer radius around our home point to this function create buffer. We just pass that into the geometry engine here with our distance and our units. And since we don't actually need to display this on the map, we then have a next final function called feature by location, and that takes that buffer geometry and we create what's called a feature effect, which is a client-side visualization based on a filter. And this filter expresses a spatial relationship. So in this case, everything that intersects with our buffer geometry. And our feature effect works on the features actually excluded by the filter, so everything outside of the buffer zone will render as grayscale. And if we wanted to, there's also an included effect property, so we could impact features that meet our filter criteria. So this is all great, but as of right now, what'll happen is if I move the slider, we won't have live updates. We'll only get updates if we're changing the Calcite input. So instead, we'll add a second event listener to Calcite slider change. And because create buffer and filter by location are separate encapsulated functions, it's really easy to reuse that code. So instead of rewriting everything inside the anonymous function that we pass to Calcite slider change, we just call these functions a second time. And now, every time the user interacts with the slider, we'll have live updates to our feature effect. And also, similar to the input event, this event only triggers when the user actually lifts up on the slider toggle. There are other Calcite events that would register, for example, on every change. But again, this is kind of a better user experience if we only listen to events that occur when the user lifts up on that toggle. So next, before our next demo, I'm going to hand things back over to Nate, and he's going to tell us a little bit more about styling and CSS.
All right, let's talk about CSS real quick. So HTML is used to define a web page's structure, and JavaScript gives those HTML elements behavior and logic, and CSS is used to style and lay out HTML elements. Now, CSS has been around for over 25 years, but in the last few years, it's really grown dramatically as browser makers like Apple and Google and Mozilla, they've all formed agreements to add specific new features to the web platform each year. And the result is that new CSS techniques are becoming ubiquitous at a very rapid pace. Let's talk about one of the most important recent features, and that is custom properties. Custom properties are also known as CSS variables. They allow you to store and retrieve CSS values, and they can change values for specific elements or under specific conditions, like a user enabled their computer's dark mode. Custom properties pierce the shadow DOM, so they can be read by web components. Component libraries like Calcite components allow specified style overrides via custom properties. And they can be used anywhere a CSS value is valid, including inside CSS functions. So speaking of functions, let's talk about the most important function when you're working with custom properties, and that is var. Var is a CSS function that outputs the value of a custom property into any part of a value of another property. You could use it as the entire value, you could use it as part of a value, or you can use it inside other functions. It's especially useful inside calc functions or inside grid layout functions like min-max. So what happens if a named property is undefined? Look here, for the font size, I've got app font size. What if that is undefined? Anything after the first comma inside a var function gets treated as the fallback, and that gets used in place of an invalid value. You can use that to reference a different var, or you can have an absolute value. Look, I've here specified 1 rem. Okay, so now.
Keep it there for just a second.
Okay.
Great. So now we're going to get into our next demo. So this is talking about what happens if we want to go mapless, and we just want to use Calcite components, but also access some layer data to create a custom UI. Leave it there for a sec.
Nope.
It'll just be easier to toggle. Can you go back to 3? Sorry. So ArcGIS REST JS is an open source library that it wraps the REST API, and it allows us to access things like, in this case, the feature layer module without actually relying on the Maps SDK. So it's nice and lightweight and really easy to import into our custom application. So now,
Oh, we got this.
that's okay.
Okay.
So this demo uses the exact same CSA pickup sites data set from Portland Open Data. And so we wanted to create a list view with some filtering that would highlight the products available from each CSA. And because a lot of the products were distinct but related, we decided to create some overarching categories ourselves to make the filters a little bit more useful for users. So here we have a list of cards with our CSA pickup sites. And this time we also included the longer description that comes from the farm. And we also used icons from the Calcite Design System to represent the farm's email address and website. So these are links we can click on. And on the right, the emojis you see represent the different product categories. And on the side here, we have a set of calcite chips. And as I select different chips, we see a little tooltip with the human readable. Oops, nobody sells mushrooms and vegetables apparently. But they do sell vegetables and berries. So the filtering responds, or as we unselect, goes back to the full list view. So looking at the code, instead of displaying the layer on the map, like I mentioned, we're just going to import this query features method from ArcGIS REST JS's REST feature service module. And this allows us to query the active CSA pickup sites and only retrieve the data that we need. So a little further down, we call query features, and we pass some parameters into the API. We have a SQL statement where status equals active from our layer data. We have the URL of our feature service, and we're also setting return geometry to false because we're only working with the feature attributes here. You can also specify only which feature attributes you'd like to return. It defaults to all of them, though. And query features returns a promise with our layer data. So then we have some work to do to get our category filter working. So what we do here is the layer is returning individual product strings, and then we remap those to a data object that I created with our category groupings and then the corresponding emojis that match each category. And this is just plain old vanilla JavaScript mapping over arrays. And then depending on, if you had a larger data set, maybe something that you owned, you might choose to do this a little bit differently. You could have a feature service that you hosted yourself, and you could do this kind of data work from the outset in the service itself. That way you'd only have to do this work once. But this is a small data set, and this is not our feature service, so doing this on the fly in the client works really well. So next, let's see. Next, we want to filter our results. So we're going to add another event listener, this time to listen to the selected calcite chips. And then all we're going to do is listen for the event that fires when the selected chips change. Once we have that, we just need to display our cards. So we're generating these programmatically, each card and its chips, and we plug in our data here, and then we just append each card to the DOM. So now Nate is going to tell us a little bit more about how styling this application worked.
Okay, great. So since this view of our app doesn't have a map in it, we kind of had a blank slate to build whatever kind of UI we wanted. And I'm a CSS developer in my bones, so I started mobile first. And that means I built the interface for the smallest screens first, and then I added media queries when I needed to change things for bigger screens. So let's take a look in this app in responsive mode so we can see the difference here. So here's the mobile layout for this app. So the biggest difference is we moved the product filter to the bottom of the screen so it's more reachable for mobile users. If this was a real app, you would probably hide that behind a menu or something. Calcite Design System has a really great floating action button that's perfect for something like this.
Oh, I think you have to exit presenter.
I stayed in presenter mode. I apologize. I'm not a PowerPoint person.
Bear with us. PowerPoint is hard. It's the hardest part about web development, actually, is working with PowerPoint.
Thank you so much. Appreciate it.
Thank you.
How's that?
Thank
All right,
you.
there it is. Okay, so let's dig through the CSS a bit in detail, and we'll see what we got going on here. Okay, so I started by making the whole body of the page a one-column grid. And then I set up grid rows for each of the element. And so take note of the FR unit here. FR means fractional unit, and that tells the grid to divide up all the available space between all the fractional tracks. And then down here we have our first media query. And this is where we make style changes for different viewport dimensions. In this case, if the browser gets wider than 768 pixels, we change the grid to have 2 rows and 2 columns, and then we add a vertical gap. And I also want to call out the min function here. Min is one of my favorite new CSS functions. Min function will return the smallest computed value from a list of expressions. In this case, I usually want the gap to be 2% of the viewport height, and that's indicated by the VH unit. But as the viewport gets taller, I don't want the gap to exceed 2 rems. There's also the opposite function called max, and we'll see that in a minute. And then for the H1 here, take note that I'm using 2 Calcite custom properties here, Calcite color foreground 3 and Calcite color text 1. That'll be important in just a minute. Moving on to the filter container, you can see that I'm setting 2 Calcite variables, Calcite custom properties with new values. I'm setting Calcite font 0 to Calcite size 2 and Calcite color foreground 2 to honeydew, because I love that color. Let me close responsive mode and I can show you here why I did that. Why would I want to override a Calcite custom property? And the answer is, of course, Pearson that shadow DOM. Since the Calcite chips use custom properties to define their styles, I can customize them by changing these values. So here I've just overridden this color to be Calcite, to be honeydew inside filter container. If I turn it off, it'll turn back to the default Calcite color foreground 2. And then why did I set the font size bigger? Well, honestly, it's just because emojis look way better bigger. If I make it small, it's a lot harder to see. But I guess it's not overwriting. And then also, I want to talk about, there's a different kind of media query here. This is prefers color scheme dark. So that's how you set different colors or different values for dark mode. Calcite Design System includes full light and dark mode themes, and you can customize those really easily, and you can switch between them really easily. So if I set my computer to dark mode, all the colors change, and everything looks great. The colors keep the same kind of rhythm of light and dark, and everything looks good. I'm going to switch back to light mode for the presentation. And let's see. Okay, so you can also see down here that I'm setting the filter container to position sticky and sticking it to the bottom of the window in mobile view. And then at 768 pixels, I move it to the top and I set the bottom down. Oh, this is why, because I set Calcite font 0 here and I'm at a bigger MIDI query. Watch this. See how small those emojis are? No good. We want them big. Okay, there's a bit more code here, but the last thing I really want to demonstrate is just kind of how far CSS functions have come recently. Down here in the card container, this is the container that holds all these cards, you can see that I'm setting the grid template columns. I've got 5 nested functions here. It's kind of ridiculous, and it's kind of overkill, but it basically lets me set a really complicated grid without any media queries. This grid functionality will work across any viewport size, and the grid will always look good. Let me kind of dig into here and explain what I've done here. So we're using the repeat function, and the repeat with the auto-fit option. So this means that the grid will create as many tracks as possible, and they'll use the size expression you've given them. Any additional columns that would cause a new line, they'll break down to the next row. For our size expression, we're using a min-max function, and that takes 2 expressions, which is a minimum and a maximum. And a min-max function will fluidly move between the 2 values of the minimum and the max, and never exceed the minimum or the maximum. So for the minimum expression, we're using the greater value between our minimum column size of 300 pixels and 25%, and making sure we'd never have more than 4 columns. So we're 25%, and then to make sure that 25% is accurate, we have it inside of a calc function, and we're also subtracting the same value that we use for the gap. So that makes sure it's always 25% minus the gap value. That was a lot. I said the words minimum and maximum a lot. Let's go back to PowerPoint. Look good? Okay, so finally, we want to talk about the most important tool when building for the web, and that is the browser. All mainstream browsers have very powerful built-in developer tools that are indispensable when debugging the web. We want to briefly touch on a few of their most useful components. The inspector is usually the default view for the developer tools. It allows you to select and inspect any element of the DOM, and you can even open custom elements and inspect their shadow DOM. Once you've found an element, you can modify its CSS properties and values and see the changes happen live. And if you're building grid or a flexbox layout, you can see a visual representation of how the browser has interpreted your layout rules. It's very handy when you're writing complex grid functions. You can see here I'm showing the grid tracks so you can see the gaps and the columns and the rows for this grid I've defined. The network component is another big part of the browser dev tools. That'll show you all the requests your browser made to load all the page elements and all the responses that servers have provided to those requests. So if you're working against an API, you can make changes to your request parameters on the fly and see what the response looks like. It's also great for seeing the exact sizes needed to send resources over the network. So maybe someone put in a 2 megabyte graphic and you catch it by looking in the network tab and sorting by size, and you let them know that that's not okay. And then responsive mode allows you to simulate different device and viewport sizes quickly and easily. If you're building for the web, it's important that your layout works across all different sizes of viewports, and this tool makes it so easy. Every browser has it. You flip on responsive mode, and you can just drag and drop the size to however big you want and see where your layout works and doesn't work and what changes you need to make.
All right, so we covered a lot of ground quite quickly, but we hope that this has given you some ideas of how to use some of Esri's offerings, such as the Maps SDK, Calcite components, REST JS, in your geospatial journeys into front-end development. Somebody on the live stream asked if we were going to show our code, and yes, we're absolutely sharing our code with you guys. This is our GitHub repo that has all of the demo code that we've showed, and also links to all of the resources that we've talked about in more detail. There's also a ton of extra learning links in there as well. Also, you'll find documentation, tutorials, API references, and more for the JavaScript Maps SDK, Calcite Design System, REST JS, all the icons we've talked about on the developer's website, so that link is there on the slides. And lastly, web development is a huge, huge, huge topic. I can't emphasize that enough. We never stop learning. We love to learn. We hope you do too. So here are some of our all-time favorites for learning JavaScript and CSS if you're newer on your front-end journeys. Highly recommend all of these links. Some of them are more documentation and guide or tutorial focused. Some of them get you guys building code quickly right away, like JavaScript 30. So just give you a minute to take a picture of that if anyone wants to. And lastly, because web development is such a huge topic, there are some great sessions coming up later in the conference that dive quite a bit deeper into some of the topics we've covered today. So we just wanted to call out a few of those today and tomorrow. This afternoon will be a deep dive into Calcite and the Maps SDK. Then there's also going to be a session on web accessibility and building apps with the Maps SDK and Calcite Design System. Web accessibility is a huge and very important topic. Tomorrow morning, if you're interested specifically in front-end frameworks, there's a demo theater on building with Calcite and React, which is one of the more popular front-end frameworks. And then tomorrow afternoon, there'll be a building with the Maps SDK for JavaScript components. We've talked a lot about web components as they relate to Calcite components, but the JavaScript Maps SDK in beta now has a set of web components that you can use to bring in the map and other elements of the SDK into your applications. So definitely check that out if you want to learn more about web components. Thank you so much for joining us, you guys. Lastly, please take a moment to share your feedback about this session. I'm sure you've seen this slide before in other sessions. This is really helpful for all of the conference organizers and all of our presenters here at Esri to improve what we offer you guys.
And we've got time for questions. So if anyone has any questions, we've got a couple online. Someone asked they could show an example of CSS changes to the components, and we did that. Yes.
Check.
One question I did want to mention, for someone online asked, an anonymous user asks, When would someone use I'm guessing that's object-oriented tools out of maybe I think that's object-oriented.
Maybe out of the box?
There's no B. Such as Experience Builder to build an app versus creating a custom web app using these tools, or should we use these tools in conjunction with Experience Builder by creating custom widgets and components? I mean, that's a very broad question.
It's my favorite answer to a question, and you all will groan a little bit. It depends. And I'm so sorry. But really, it depends a lot on your individual use case, right? You know, some of you may be inheriting legacy code bases that already are using configurable app builders like Experience Builder, and so you may feel the need to customize those or add on to them. Some of you are starting with blank canvases and have the ability to completely greenfield something. The good news is that all of Esri's different offerings play very nicely together, and the teams are constantly trying to make those even more interoperable so that no matter what tools you'd select for the job, our goal is to make sure that they play as nicely together as possible and really make that easy for you guys. For specifically with Experience Builder and customizing widgets, I would definitely recommend speaking with the Experience Builder team directly in the showcase because they've got some great subject matter experts over there.
Any questions? This person asked if we could show the resource links again.
Oh, sure.
Back
Yeah.
slide.
All right. Oop, one more.
Yeah, and definitely get that GitHub link because we also have a resources document in there that has a bunch more links that we couldn't fit on this tiny, tiny slide. Any questions in the audience we can answer? Go ahead. It has, so Calcite, the question was, does Calcite Design System have any specific size classes like Bootstrap that can change sizes? So Calcite Design System has the concept of scale, and most components have a small, medium, and large scale, and you can even set that kind of like higher up and say like, okay, I want everything in here to be scale large or scale small, and it kind of filters down. It doesn't have the concept of like, saying this is exactly 32 pixels or something like that, because everything needs to be fluid and everything needs to be flexible. But they do have the idea of scale, so you can, change certain elements in relation to other elements. Does that answer that? Thanks. Go ahead.
Yes. Oh, yes. So the icon, the Calcite point system icons. Oh, yeah. So there are two different links that you'd want to do. The Calcite point system is in the Calcite design documentation. This is all listed in the GitHub repo, too. That's where you'll find those point SVGs. And then the symbol builder app is actually a web application. And there's a link, and also I found a really great blog post by the JavaScript team about some really cool things you can do to customize and layer. You can not only do point symbols in the symbol builder app, you can also do lines and polygons and create custom fills as well. It's really cool. Definitely check it out. I'm sorry we didn't have time to demo that.
Here's another online question. Walter asks, I have an app and I'm moving from JS API 3 to 4. Do you foresee any issues just changing the UI with Calcite components, leaving all functionality in place that uses jQuery to access the DOM and Ajax to interact with the backend? Best answer is going to be, it depends. For the most part, I don't think so. For the most part, you can usually just drop in Calcite components and wire up their functionality to your existing calls. Most of the Calcite components have really good events and event documentation, and it's pretty trivial to plug things into those events. I'm not saying it's going to be easy, and there will be issues, but I, without looking at your app specifically, we could never tell exactly what the issues would be.
We're developers, right? Of course there will be issues. I will say, too, there are some great docs for migrating from the JS API version 3 to version 4, so definitely check those out. And for folks at the conference, the Maps SDK team is live in the booth, and they are very eager to talk to you guys and answer questions, so please go visit them. Other questions from the audience? Our in-person audience? Anything else from the street?
No, not yet.
Great.
Would be an awesome MOOC.
Someone online asked if either of us will be offering online courses for more in-depth learning. I love talking about introductory front-end web development, so I'm definitely not opposed to the idea, but no plans as of yet. Yes? Yes, definitely. Oh, sorry. The question was, any recommendations for other resources for just getting started learning web development and JavaScript and CSS besides what's listed on the slides? We did include more resources beyond what is on these 6 links in the GitHub repo. I do think, MDN Web Docs, while that title sounds really dry, in addition to the more granular API references, they have a lot of really wonderful guides. They're authoritatively written, you know that you're getting the best of the best. Like, that's where front-end web goes to be documented, and so I would definitely recommend checking them out. For JavaScript, besides what we've listed here, I would say the sooner you can start playing around in code, the better while doing your reading. There are a couple of tools we listed in the resource links, like StackBlitz. That's a tool that allows you to start developing in the browser. You can even do things like start installing dependencies from the Node Package Manager. The nice thing about that is that you can really get started playing around quickly without having to set up a development environment locally. So it's really, really fast and a lot easier to start prototyping that way. Yeah.
Someone online asked for a link to the symbol builder, so I'm going to go ahead and post that in the chat, but it's also in our resources document for people that are here.
The cool thing about the Symbol Builder app, too, in addition to the CIM symbols that I talked about, the Symbol Builder app supports building any symbol, I believe, that's supported in the Maps SDK with no code, and then you can export the output, whether it's JSON or something else, to just drop into your application. So all I did when I built that symbol is I copied the JSON from the Symbol Builder app, saved it as a file in our own project, and just referenced it as a variable when I imported it into my JavaScript file.
And answered.
Answered.
Any more questions? Nobody has a complex CSS grid layout that they can't solve?
Well, if you think of any other questions and you walk out of here or at lunch and you're like, shoot, I forgot to ask Davis and Nate a question, we will be over in the booth in the expo area. Look for us either at the web development area or in the ArcGIS platform area. And thank you so much, and enjoy the rest of the conference, you guys.
Thanks, everybody.